Welcome to today's customer case study webinar, STT Connect builds Nimble cloud infrastructure with next-gen SDN. My name is Judy Ash, and I'm the head of corporate marketing here at Big Switch, and I'm your host for today's webinar. And joining me today are two very important folks on our team. Firstly, Dave Robinson, who is the CTO of STT Connect and a customer in our ASEAN region in Asia Pacific, Japan. And Luke Turner, who is our Director of Systems Engineering for the Asia-Pac Japan region for Big Switch Networks. As we go through today's presentation, we welcome your questions and ask you to use the Q&A box on your webinar dashboard. Some of you may be familiar and know it's pretty easy. Just enter your question. It shows who's asking, and we will do one of two things. We'll either answer the question live in our conversation, or we'll follow up with you directly and answer your question offline. If you're watching this video on demand and have questions about the information or want to suggest another webinar topic, please email us at info@bigswitch.com. Additionally, we've provided handouts for today's session. One is the case study on STT Connect, written up with some fairly good information about the implementation, the benefits, and the results. And the other is on our Big Switch Labs environment, which allows you, if you're interested, to explore more further. We'll talk a little bit more about this later in the session, but that handout tells you a bit more about Big Switch Labs. We have a full agenda for today's program. Let's get started. I'm going to turn the presentation over to Luke, who will moderate the next portion. Luke, on to you.
Thanks very much, Judy. I'm going to introduce Dave Robinson, who is the CTO for STT Connect. Dave, why don't you tell us a little bit about STT Connect?
Certainly, thanks, Luke. STT Connect is an enabler and manager of flexible web-scale private cloud, which is built on a secure enterprise-grade infrastructure that meets the most stringent of industry requirements. We integrate some of the industry's best technologies to deliver high-performance compute, storage, and network through our core solutions: virtual private cloud, dedicated private cloud, as a standalone offering, or as part of a multi-cloud strategy. Our solutions are backed by industry-leading service-level agreements, expert support, and certified by top industry standards, including ISO 27001, and of course, Singapore's highest standard for multi-tier cloud security, MTCS Tier 3. Tier 3 is the highest level, which stands STT Connect amongst global cloud giants. Taking a personal, consultative approach, we offer flexible and scalable solutions to help businesses rapidly achieve agility while providing more flexibility and control over their IT resources. STT Connect is a company of ST Telemedia, STT. STT has a strong track record of being a value-creating shareholder. Its investment approach is focused on building a strong portfolio of complementary businesses to enhance capabilities and capture adjacent growth. As a portfolio company, STT Connect has benefited tremendously from our shareholders' deep industry experience and group domain expertise, and of course, strategic partnerships, particularly in data centers, technology infrastructure, and software. So, who is STT Connect? Our vision is to be the cloud provider of choice for ASEAN as businesses evolve to the next generation data center. As I said, we deliver infrastructure as a service, integrating the industry's best technologies into a flexible service offering, making cloud more reliable, affordable, and of course, a trusted partner to companies of all sizes. So, how did we actually start? Well, when we started this journey, our objective was to deliver a high-performance, open and secure cloud platform. And of course, going through this, there was a number of options that were available to us. We ended up deciding on OpenStack for a number of reasons, because it provided, it was an open source product, it had good momentum, and it was able to provide the self-service functions from compute, network, and storage. As we started going through that, we looked at it to truly meet web scale and how it would fit into our business from an agile organization. And there were a couple of areas that we identified which were lacking. One of them was around storage. So what we did was, instead of using the storage that come with OpenStack, we actually moved to using Ceph and providing that for both block and object storage. The other, which was even more important, was actually around networking. For those who are familiar with OpenStack, it uses Open vSwitch and it's actually controlled by Neutron. It's a great product, it works, and for most enterprises, it's able to fulfill a certain amount of requirements when things run well. The problem is we're a service provider, and when things go wrong, we can't be blinded to what's actually happening on the network. So we actually went out to the market and we looked at who was out there who could provide software-defined networking services, who were able to help us meet our requirements. And of course, we ended up choosing Big Switch. And I'll talk a little bit more about the requirements that we had when we were looking for an SDN provider. So from a network, there were a few things that were important to us. One was it needed to be a modular design. And what I mean by that is, as we expand into the ASEAN market, we need to be able to start with a small footprint that's able to provide those services whilst we nurture the market, and then we're able to add and extend that to meet the growing demands. And again, remember, this is web scale. We can't keep changing our design as it gets bigger and bigger and bigger. So of course, the pod design concept is an important component to that. The other is it had to be highly available. And when we talk highly available, this isn't just your, everything redundant. We're talking highly available in the sense that if I lose my control plane, if I lose my spine or my leaf, things are able to keep functioning. SDN has a control fabric. That control fabric is the brains of the organization. In the event of a catastrophic failure of that, the rest of the network needs to continue to function. And that was an important component and something that Big Switch was able to achieve. It had to be scalable. It has to be able to handle thousands and thousands of compute nodes, and it has to be able to evolve to meet the growing demand of cloud in the ASEAN market. No single points of failure. This is an important one. Equipment breaks. It always happens. But throughout that entire design, from the edge, from the core all the way down to the lowest component of that system, there cannot be any single points of failure. The cloud platform has been built with an N+2 architecture to ensure that even if we actually have multiple failures of a component, it's able to continue to function and operate. This is important for us to be able to offer enterprise SLAs. We need a single pane of glass from a management perspective. And this isn't just about the network, but this is also from troubleshooting. To give you an example, if you're looking at the native networking that comes with OpenStack, you have to go and download third-party plugins for Open vSwitch to try and see what's there. It is not intuitive. It is not something that a service desk person could look at to see where there's a problem. It's not something an operations center could manage. These require advanced technical skills. It also is a little bit of a black art in that you need to actually be able to understand very deep, complex networking, functions or technologies to understand where it's gone wrong. One of the benefits we have with Big Switch is it has a graphical representation of our network. From a service provider perspective, if a customer's having problems, we're able to simulate the issues that they're experiencing and identify whether that's a network-related issue or whether it's an issue with a firewall setting that they've had. This is an amazing feature, and it's one of the ones that stands out from my personal view of where Big Switch excels. And of course, the final one is it needs to be zero-touch management. And what I mean by this is we treat infrastructure as code. And with that, I don't want people logging on and going to a console and making small changes. There's a terminology which I like to use, and I honestly can't remember who said it, but it's treating infrastructure as pets versus cattle. If you treat it as a pet, you name it, you groom it, you have to take care of it. It makes it extremely hard to manage, and it also makes it hard to maintain agility within an organization. We want to treat everything as cattle, which is just a number. That means it's a commodity. If something goes wrong, we dispose of it, we redeploy a new one, and we keep handling and going forward. This is where the zero-touch management comes in that if I lose a network switch, it needs to be as simple as putting it in the rack, plugging in the cables, entering a MAC address, and it's up and running again. And that's something that we've been able to achieve. Can
we just dig a little bit deeper on this? So you've talked about deploying an SDN leaf-spine fabric with Big Switch, which you've deployed in multiple data centers. Do you have any traditional legacy network equipment left within your design?
From the cloud platform itself, so within the pods, no, it's all SDN. We've replaced all of the equipment that we had in there. Our only remaining legacy network equipment is actually our core, and this quarter actually we have a project to replace that, so everything will be virtualized. The reason being is that we're able to then programmatically manage that, and we can actually do everything from a code based. So there's still a tiny little bit in there, but that's going away.
Oh, I'm sure it's very hard to just jump into the deep end. There's always a process of migration. We rarely get greenfield designs these days. There's always an element of brownfield and migration that needs to be achieved. Another thing I just want to quickly dive into a bit more. So, you've talked about the modularity of the design. So for example, at the moment with your current DCs that you've got deployed, when you build a new DC, so when you open up a new market, and you start with the foundation racks, which we see on the screen there, being the two main racks with controllers and spine switches, and you deploy that in a HA configuration, then when you scale as per your customer requirements, you're just adding compute racks. So I suppose the question is, how does this help you from a business perspective?
Actually, this helps us a lot. One is that I can get a rack fully configured and actually ship an entire rack. And all we have to do is plug in a cable from the spine into the leaf switches at the top of it, enter the MAC addresses into the control fabric, and it's auto deployed. The other is we use Red Hat from OpenStack, so we have an undercloud and overcloud. The good thing with Big Switch is that all of that configuration is able to be embedded into the configuration files for the undercloud. So when we deploy our controllers, additional compute nodes, they are 100% configured, ready to go within a matter of hours. There's no more, making manual changes. There's no room for error because it's all goes through a proper CI/CD pipeline with full testing.
So it's very cookie cutter for you guys.
Extremely cookie cutter. It's probably one of the biggest challenges we had was actually getting everyone to embrace, treating infrastructure as code. And the good thing is that it enables us to innovate fast because we can make changes, we can test, we can come up with different hypotheses on what we want to try and achieve, and then we can deploy it. And if it works in our staging environment and it passes all of our performance tests, integration tests, and a multitude of others, we're able to make small incremental changes to the rest of our cloud platform. And that provides benefits to the customer because the customer is able to receive all of those benefits in a non-disruptive fashion. The customer themselves may not see it, but we as a service provider, it makes our lives a lot easier, which means that we can provide and delight our customers.
Okay, great. Thanks for that explanation.
Okay, so this one is just a little bit about the cloud platform, just to put it into more context. So at the top, we have the Big Cloud Fabric, of course, which is integrated into our OpenStack platform. This provides us with a shared network architecture, and of course, it's designed for full redundancy, resilience, and of course, performance. It also enables us at certain compute nodes to actually offer different configurations. So those that are optimized for storage, those that are optimized for I/O, and of course, those from a network perspective, such as SR-IOV. This also actually manages our storage fabric and of course, our storage fabric is really designed for three main profiles, which is high IOPS, throughput, and capacity. And of course, the entire cloud has been built with security in mind, and of course, in a fully HA and resilient manner. I'd like to say that we did this all by ourselves, but it's never the case. When we were going through this, we made sure that we partnered with people that had the same vision, the same desire to actually delight customers, who also embraced open source and open standards. So we host our equipment in the ST Telemedia Global Data Center data centers. We have our network provided by Big Switch. All of our infrastructure, storage, compute, and network is all Dell EMC. And of course, our OpenStack is actually Red Hat, and we use tools such as Ansible for the automation components as well. The reason we partnered with Dell EMC, Red Hat, and Big Switch is from a certification perspective. Our platform needed to meet very stringent requirements from common criteria, so EAL4 and others. And these partners actually enabled us to address the most stringent of security requirements for us to get our industry certification. And of course, Armor is there. We have a partnership with Armor, and Armor actually helps protect not only our underlying cloud platform, but it also helps protect the virtual machines and the instances for the customer. Because one of the problems with general cloud is once you sign up, they say, here's your cloud, here's all your instances. And unfortunately, people forget about security, or they think that security is provided by the other providers. We have Armor as part of that. And we recommend to customers that they should actually, deploy Armor onto each of their instances, as that provides them with full end-to-end security. So everything from the facilities all the way out to the applications is then protected.
Dave, I just want to ask you a quick question. So you talk about certification, and I know that you guys went through quite a rigorous process to achieve MTCS Tier 3 certification. Do you just want to explain a little bit more about what that certification is and how that has helped you guys with the customers that you can now attract?
Certainly. So MTCS Tier 3 is a Singapore standard for multi-tier cloud security. Think of ISO 27001 and ISO 9001 on steroids is probably the best way to describe it. There are 534 standards that you have to meet as part of that, and you have to achieve 100% compliance across every single one of those to achieve Tier 3. And that covers everything from cloud administration, data sovereignty and data protection, network isolation, which is actually an extremely tough one. It also talks about data flows. This is designed, and the Singapore government set this up in their foresight and wisdom, because as more and more businesses move to the cloud, you need to have a level of assurance that anything you put on there is protected, that the organization is running to the highest of standards from both process and procedures, as well as they're taking security, reporting, and your data privacy as their #1 goals and objectives. I've been in IT for many years, 25 years, probably coming closer to 30 now. I'm starting to feel a little bit old. And of all of the certifications I've done, this is probably the hardest. Actually, this is the hardest. And we've got an amazing team. They've done a great job, and we achieved this certification in an accelerated time frame. And having the visibility that we got from Big Switch for the network definitely helped us along this journey. I would hate to have tried to achieve this without you guys.
Oh, that sounds like quite an achievement. Especially using best of breed and newer style technologies which you've deployed.
Well, the good thing is we were actually the first to get that certification using open source. So, that is credit to the entire team who worked tirelessly to make sure that this platform was secure. And of course, the thanks to yourselves and of course Red Hat for their help along this as well. It's a great achievement. And for customers, it's a major benefit because you know that we take security, privacy seriously, and that, you know, we're never going to stop.
Okay, great. Thanks for that. I'll let you continue.
No worries. So I'd like to tell you that everything was smooth sailing and we had absolutely no issues at all, and it was a great journey. It was a great journey, but we had our challenges. And in the context of this webinar from a networking perspective, the biggest challenge that we actually faced was around traditional network thinking. And this was probably the biggest challenge that I actually faced. Was network people, you know, love to jump onto consoles. They like to treat the infrastructure as pets, using the pets versus cattle analogy. And the old core access and distribution has changed. SDN completely changes all of that. And it took a while to actually, you know, break down those barriers. And it was even a harder challenge to get them to embrace treating infrastructure as code, which meant anytime they wanted to make a change to the network, it had to go through a full CI/CD pipeline. We got there, and how we got there was we started with the why is it important. Anyone that's worked in operations knows that if you want to make a network change, it's usually between the hours of midnight and 6 a.m. And then you've got to come to work and do your normal day. The whole reason why we pushed this was, if you put this through the CI/CD pipeline, if you treat this as code, then you don't have to do the midnight changes anymore. You know that everything is consistent, and, you know, there's no deviations from that. If something goes wrong, we have a fast rollback. And it also means that you don't have to do the menial tasks that come with any form of administration, whether it's, you know, system or network. We can actually push those down to other people because we actually have a process in place. And that works. And the team has embraced that. We got a few quick wins just to show them that there was value in that. And, you know, it's humming along nicely now.
Coming from a traditional networking background, I can sympathize with you there. Us network engineers historically love complexity and things like BGP. And I remember having these discussions with you early on in the piece and explaining, you know, the newer ways of doing things.
And look, complexity is actually something that I think our industry as a whole is embraced, because it keeps us in that mysterious corner in the, you know, in the organization where people go, you go and deal with those people because I don't understand what they're saying to me. Now we have to evolve to actually start providing business value, and complexity doesn't have a place anymore. I still remember when we were going through the actual training on Big Switch. And by the way, love Big Switch Labs. At the end of the training, and this was a one-day training course, at the end of the training, I actually went and said, so what's missing? This is all too simple. There has to be something more complex. You know, you're not telling us everything. And I remember the response I got was, everyone says that. And the founder of Big Switch, Kyle, actually even wrote an article about it. So you guys have done a great job simplifying SDN.
Thanks, Dave.
No worries.
Did you want to just talk a little bit more about some of the benefits, you know, for instance, like with, you know, how you're using the API and the container integration use cases, which you can start to move to?
Definitely. I was giving you a chance on the challenges, but I'm happy to go into the benefits. Probably the biggest benefit that we've got is everything. And I do mean everything is virtualized now. And that makes treating it as code so much easier. The other is we can now make changes programmatically. So no longer, if I want to make dynamic changes to the network, does it have to just be done by the network team? This is truly around DevOps and agile development. I've got developers who can make changes to the network for the customers. It allows us to then extend those services. So we now can offer NFV, VNFs, and other functions, all from a code base, and treat it as software. This makes life great. The other is all of our platform, from the network all the way down to the storage, has APIs that can be accessed from third parties. This makes it so much easier to achieve true multi-cloud. The other is Now that we've built the foundation, as we start moving into containers and serverless and a whole range of more advanced technologies, we don't have to change our network. So, for example, there is integration already with Kubernetes as well as OpenShift from Big Switch. So there are no changes that we need to make on our network. We can deploy the containers. It allows fast acceleration for customers. The other is, I had a meeting yesterday afternoon with a partner, and we were talking about adding in new services that they could provide. And what actually really just resonated, and I wanted to mention it today, is as we're talking about these services, the integration is so easy because I can plug it into our BigMon fabric, which allows us to do service training. So what would have required significant re-architecture, rework to implement this is now very simple because I can just plug it into our monitoring fabric.
And so with that capability, later when I talk a little bit about Big Switch, I mainly concentrate on our big cloud fabric. But using the big monitoring fabric with our inline mode, this allows you to then sell things like security as a service, IPS as a service, and firewall as a service. So I assume this gives you, a lot more flexibility and additional ways for you guys to service your customers.
Definitely. That is one of the biggest advantages of that. And again, it's easy to turn on and off on a per tenant basis because it's simple data flow. There's, again, no more, major changes or major development work just to actually extend a service offering to a customer, which means that we can experiment and roll out new services faster and faster every day. This is a major advantage. And the last two, because I could talk about this all day, is just we've now moved to commodity equipment. And the benefit of that is I don't need specialist monitoring equipment to monitor my network, my storage, and my compute. They're all server. They're all commodity equipment. I no longer have vendor lock-in, so I can replace this equipment as and when required. And the other is, it's, equipment failure is not a major issue anymore. If I lose the control fabric, if I lose the spine, the leaf, it's as easy as taking it out, putting a new one in, plugging the cables in, and our biggest challenge now is actually typing the MAC address in correctly. And that's I'm still trying to find a way to automate the MAC address collection and entering, but that's how simple it is to treat equipment failure now. That makes my life and the guys from an operations perspective a lot easier to maintain. So going through this journey, really these 5 lessons, I just wanted to touch on because as we've gone through, this is what we've started to, we've experienced. And if you're undertaking a journey towards anything SDN, please don't forget these. 1, operational maturity matters. Whether you're moving to the cloud, whether you're building a cloud, whether you're doing multi-cloud, you need to understand how all of this ties into your daily operations. From my perspective, having this fully virtualized makes that a lot easier, but please don't forget that. The other is embrace open source and open standards where you can. The benefit to that is if it doesn't do what you want, you can write code, you can do it yourself, commit it upstream, and other people can benefit. Never forget the users, right? Whether they're internal or external users, everything you do has to be about users before, during, and after.
Can I just ask you a quick question on that?
Sure.
Can you share the best practices for how you guys stay focused on the users before, during, and after your deployment?
It's actually a tricky one, but because we start to treat ourselves as users and we start to think, well, hang on, I'm the user here, so it's not an issue. At the end of the day, we have a very simple vision, which everyone in the team's fully aware of. We have all been consumers of cloud services, and we have to keep reminding ourselves that, as techies, we like complexity. It's not about complexity. It has to be focused on the business. We actually have personas done up of our customers, and when we're actually making changes or when we're doing anything, we look at those personas and we ask ourselves, is this actually going to add value to that person? And that's really the only way that we can do that. And of course, because we're doing agile development, we have a fast feedback loop. If a customer says to us, provides us with feedback, positive, negative, whatever it may be, we're able to take that and we're able to act upon it quickly to mitigate that or to address their concerns and keep going forward. That's probably the best thing I can say about users. Understand who they are, put a face and a name to them, and design what they want.
Great, thanks.
That one ties into the next one, which is organizational culture. Any company, even STT, it's an amazing company, but their background has been, as you saw from the original slides, around investment. We've come in, a cloud platform is a software business. And as part of software, we have agile mindsets. We run everything in an agile state. You can't forget about the larger organization. You have to show them the benefits to agile. You have to, bring them along the journey. You can't just say, well, if I can do this in 2 weeks, why does your process take, 6 weeks for me to achieve something? You have to look at the whole value stream, and you have to start just, working back and, showing some success with agile. Once you get that, it's a lot easier to accelerate these types of projects within a company. Don't go big bang. Small victories show success.
I just want to dig a little bit deeper on that. So I know you and I had a lot of discussion on this during the project, and that there was a challenge of changing the culture and mindset of the technical staff who didn't believe that a cloud-based SDN solution would be the answer. So, you've talked about not just technical culture, but organizational culture. How did you change the minds, or how did you guide the technical staff of STT Connect through this to deliver what you've got now?
We always start with the why. Why is it important to them? What's the benefits to this? And you have to give them a voice. They have to be able to tell you openly why they think what you're saying is crazy. They have to, if they have their voice and they can say it, you acknowledge it and you say, well, let's just test it. We're an agile organization. Let's test this and let's see which one works best. And you need to have those small victories. You need to show them that, well, look how easy it is for me to do this now. It might take a little bit more time up front to do it, but now I've deployed it 100 times and you haven't been involved. Do you want to be involved in those 100 times? And it's those small incremental changes without trying to go big bang that help. There's no silver bullet. There's no, if I give them, this speech, they're going to believe me. You have to acknowledge their doubt, and you have to, prove to them that this is the right way, and let them come along that journey with you.
Right.
And it was tough. We had a few, heart-to-heart conversations, because even I'm guilty of it. Sometimes you just go, it's so quick if I just jump onto the console and make a quick change. You need to have visibility as well. So, if they do it, you need to be able to say, I saw you make this change. That's against our policy. And then, you work on that and you keep moving forward. It's a long journey, but we've got there. And as I said, I've got an amazing team and they do me proud every day. And of course, the last one, and I'll hand it back to you, is don't go it alone. Partner for success. Find those people and those companies that have the same vision and the same objectives that you have, and work with them to change the world.
Thanks, Dave. I appreciate that insight into STT Connect. So guys, what I'm going to do now is I'm going to briefly talk about Big Switch, a little bit about our history, and which helps sort of set the scene as to the solutions that we've made. And it will just help tie what STT have just talked to you about and how that relates to our technology. So as a traditional network engineer, I've been in this game for quite a long time. I have a long history of deploying legacy networking solutions for integrators throughout the ANZ market and also into Asia. And over time, networking has become more complex. The more the data center grows, the more complexity that seems to come in. We end up with multiple VRFs, multiple routing protocols, multiple layers, And then we say, okay, we need to now apply security. So how do we get traffic through our security devices? How do we load balance things? And slowly, as the network grows due to the rest of the environment growing, we end up with exponential complexity. So, you know, Big Switch was born essentially out of a Stanford research project about 7-8 years ago. And the idea of this research project was a lot of really clever people that knew networking had to change, and we had to reinvent what a network would look like within the data center to solve some of these complexities. Interestingly enough, 3 groups came out of this, or 3 groups were part of this Stanford research group. So there were a lot of engineers from Google Networking. Nicira came out of this, which now became, obviously you guys would be aware of, with VMware NSX. And Big Switch was the other company that came out of this Stanford research group. So essentially, I'll get onto a little bit more now what makes up some of the key principles as to how companies like Google are deploying their data centers and why it's different to the traditional way of deploying a data center. There's 3 key things which goes into a next generation data center fabric that Big Switch made. And we refer to these as hyperscale-inspired principles. So the first principle around the hyperscale design is basically around using open networking hardware. So this is the concept where you take an open networking hardware switch. You might have heard of it being referred to as a white box, or bright box, which stands for branded white box. And this is the concept where we take a switch, there is no software on it, and we add software on top of the switch in a similar manner to how the server industry has been operating for many years now. So for instance, you might choose a server, you then choose an operating system to put on top of that based on the use case you're trying to achieve. Networking's been stuck behind for quite a long time, and we've ended up with these vertically integrated stacks. So now we're separating the hardware and the software layers. What we also do, which is a key concept, is we use an SDN controller. So we centralize the control plane. So on each one of the open networking switches, there will be a Big Switch operating system. And that operating system on the switch essentially will talk to a SDN controller, which is where you do all configuration, you do all troubleshooting, everything's done from a controller. And I have a analogy which I'll use in a slide shortly, which will help explain this in a little bit more detail. Another concept around building the DC networks is actually the architecture around using a core and pod design. So I know Dave touched on this during his section. So traditionally we went from using a core and distribution and access layer within the data center. And what we now start seeing is that we deploy pods. And a pod is an atomic unit of networking, compute, and storage built to a certified design. And so, you know, we typically see pods of various sizes, and all of these pods will be connected in a data center via generally a layer 3 core. So with these 3 hyperscale-inspired designs, essentially we have 3 products where we use this architecture. So we have a routing and switching data center fabric, which is called Big Cloud Fabric, which is what Dave has sort of alluded to and we've talked about. We also have security fabrics, which we call BMF, which is Big Monitoring Fabric Inline, which allows us to do transparent security service insertion. And we also have monitoring fabrics, which provide deep visibility into wire traffic on the network. So this is the metaphor that I like to use. So I talked about our Big Cloud Fabric using spine and leaf switches. If you think about a traditional chassis switch, and in one of those traditional chassis switches, we have supervisors, we have line cards, and we have backplanes. When we build a data center fabric, essentially all we're doing is turning that into components. So the supervisors, they just become our controllers. And this is just software which runs on top of x86. There's nothing proprietary at the hardware layer. The backplane of a chassis, they become the spine switches. And the sole purpose of a spine switch in our fabric is to just move traffic very quickly. It's not something that you touch, it's not something that you configure. All it does is allow you to horizontally scale between the leaf switches. And the leaf switches, essentially, they just form the role of a line card. So you're now not confined to a chassis like a 6-slot chassis or a 10-slot chassis. We're able to take commodity hardware and horizontally scale across the data center. And we can even grow a fabric up to 128 leaf switches, which is typically 64 racks in just one pod. And in this, as this fabric, it is all controlled via the controller. So for instance, you're not configuring BGP, you're not configuring OSPF, you're not configuring spanning tree. It all operates like it's one big switch. Hence, that's why we named the company Big Switch. Next slide. Okay, so I've talked about, how we simplify the network. We simplify things like multicast and unicast routing by building a fabric. But here's where some of the really cool stuff comes in. We take that one logical switch within the data center, and via an API, we then integrate it into a lot of orchestration platforms. So these could be things like, HCI, so using Nutanix, it could be using VxRail, could be using vSAN from VMware. We integrate with Red Hat for an OpenStack perspective, which is exactly what STT Connect have done. We also support things like OpenShift and Kubernetes as well for containerized platforms. When you think about what containers, and the benefit that containers bring, the idea to instantiate containers at an extremely fast rate, that has a massive effect on the network. And via these orchestration platforms, we can programmatically configure the network to match these dynamic environments. And one of the, I've talked about the API, but one of the key features is that we offer a CLI and a GUI to be able to program the network. When you actually use that CLI or you use the GUI, that's just making REST API calls. So the way that we natively configure and control the network is via the REST API. So now I'm just going to introduce the four, what I would say the most main use cases that we see our customers deploying, but this is growing rapidly with every quarter. So for the enterprise world, what we mostly see is that a lot of customers are using VMware. So what we do is we take that controller and we actually integrate it into vCenter. And what this allows is for us to not only integrate with the orchestration platform, but provide automation. So when you connect a new server to the network, we automate all the layer 1 properties and create the lags and the port channels. We automatically create the layer 2 segments in the network based on the port groups that you define in VMware. And then we enable routing and switching. And this is all done by not actually configuring the network as a separate entity. So your VM admin can deploy traditionally the compute and the storage in a very short period of time. Now they don't even need to create a network ticket to do some of the basic network tasks like dragging a VLAN across the room. We also support use cases around NSX. So we become an intelligent underlay because NSX obviously is an overlay and encapsulation technology. So one of the key things we do there is we provide visibility. So we can still see the actual VMs which sit behind VTEPs, and we can trace the path across the network, and we can also do things like hardware VTEP. So the whole idea is to make the underlay and the overlay to act as just one intelligent network. The next use case, which largely is what STT Connect is about, is around OpenStack. So they've deployed OpenStack with Red Hat as the flavor. And we refer to our integration with OpenStack as P+V. So P is the physical switches that we control in the network, but uniquely, we also control the virtual switches. So we have a user agent which ties into Open vSwitch, and this enables end-to-end visibility across the network. It allows us to do things like routing and NATing at the vSwitch layer, so we don't have to hairpin traffic back up to the physical component, but we also get the visibility across the entire environment. Another use case is containers, which I've already alluded to. So we typically see a lot of Kubernetes and OpenShift out there. And like I was saying before, that the environment becomes very dynamic when we're using containers. It matches Dave's analogy around the pets and cattle. For this, we also deploy a vSwitch, which connects to our controller and gives us similar automation and performance benefits that we get with our OpenStack solution. And then the final use case is deploying just a data center fabric. So for instance, we deploy the simplicity of our BCF fabric, so it just being one logical switch, and we get unicast, multicast benefits. We simplify upgrade processes and monitoring and management, but we've now got a platform that we can integrate into other types of solutions. So this is very unique to Big Switch, and this is what I like, or one of the, I suppose, the killer features. You know, from a multi-tenancy perspective, we've long been able to virtualize the data plane. So things like VLANs and VRFs, which obviously we also do within Big Cloud Fabric, but we abstract it slightly. But one of the key things is that a tenant is a first-class citizen in our fabric. And on a per tenant basis, we can integrate each tenant into a different orchestration platform. So let's say at the moment you've got, you're putting in a Big Cloud Fabric and you connect it to your standard vSphere environment from VMware. So you can start to achieve all of the automation, integration and visibility. But then you might have a new project where you want to start to look at some of the benefits of NSX. So for instance, micro-segmentation. So on the same fabric, we can then spin up what we call or refer to as a vPod. And we can have an NSX environment and a vSAN and vSphere environment running side by side. You then might have a requirement for things like OpenStack. So you want to start to look at the benefits of what STT have been talking about today. And on the very same fabric, you don't have to then go and implement another network. You can use the same network and still achieve all the automation benefits. Things like overlapping IPs, overlapping VLANs, and this is a key feature that we offer for multi-tenancy for things like service providers and managed service providers. Okay, so this is essentially is my final slide that I'll run through before we move on to questions. But this is a very resilient network that we've deployed. It is a converged layer 2, layer 3 fabric, which means it can converge faster than any traditional ECMP network using protocols like OSPF and BGP. So we have a test that we do, and we run this test for a lot of for every piece of software before it goes out to the door to companies like STT and Verizon. And what we actually do is we run this test for a 30-minute period. And during this test, we will fail controllers over, we'll fail links over, we'll fail switches over. And with a fully populated network with 1,000 neutron networks all running Hadoop, we can essentially have no impact to application performance. And we're handling double, triple, and quadruple failures during this process.
Actually, we can verify this. Luke, we've done the same test, even just pulling the power cables on the back of the control fabric, and the network just keeps running. It's extremely resilient.
Okay, great. Thanks, Dave. From a perspective of just describing the solution from a holistic view, that was all that I planned to cover in today's webinar. I'm happy to open questions to myself or Dave. If you don't have any questions you want to ask now, like Judy said, you're welcome to email us and we can answer those questions offline to you. Dave, is there anything else that you would like to talk about us?
I'm actually really good. This has been a great session, and thank you for allowing me the opportunity to present our story.
So Luke and Dave, thank you very much for your time. The whole implementation and the new line of business is pretty exciting. And Dave, congratulations to you and your team for not only the effort, but just the just the overview of the business, and we'll be watching as you grow and certainly partnering with you. And Luke, thank you very much for the insight on Big Switch and the way we operate and work with customers. As a reminder, if you are listening to this on demand, please email us at info@bigswitch.com with questions. To those who are on today, please don't forget to download the handouts from your Handouts tab on the dashboard. The STT Connect story is there. For Q&A is Saman Zayed, our Director of Systems Engineering. Just to remind you, if you have questions and you want to submit them using the question box, please feel free. You can see that in the question box on your webinar dashboard. Let's go with the first question, which is, what are the benefits STT achieved from using physical and virtual switch software from Big Switch versus using OVS as example?
Yeah, so very good question, Judy, and thanks for asking that question. So as both Luke as well as Dave pointed out, that we really have two models of deployment. We call one model as P only, and where basically we are providing the software just for the physical switches. And then we have the P plus V model, where we are not only providing the software for the physical switches, but also for virtual switches inside the host. One of the big benefit of that model is that it gives our controller the ability to manage end-to-end networking, including physical and virtual, provide visibility, provide benefits like distributed routing for IPv4 and v6, NAT integration, and just the simplicity of upgrades. With OVS, it's more of a ships in the night model, where basically, OpenStack controller is using a default sort of neutron, networking, whereas, with the P plus V Big Switch model, we are using the Big Switch to neutron plugin to provide the networking for the virtual environment. So the big benefits would be visibility, monitoring, troubleshooting, and performance.
Yes, and I think that's clear in Dave's comments as well, and what allows his team to really act fast as they manage the services that they deliver that are really very, very dependent on the network, truly. Yep. One other question that has come in is, what kind of container integration does Big Switch provide?
Yeah, so thanks, Judy. So we currently provide integration with Kubernetes, OpenShift, which is a Red Hat distribution for Kubernetes, as well as Mesosphere. And this is actually one of the use cases that's becoming more and more common and popular. One of the things that I think Dave pointed out, that even though they started with OpenStack, they definitely have a roadmap or a plan to get to containers and offer that as a service as well to their end customers. And one of the things that we do differently, particularly in Big Switch, is just the way our controller works in terms of a common single API from the BCF controller, which makes it very, very simple and easy for us to integrate with any kind of virtualization platform. So even though today we integrate with Kubernetes, OpenShift, and Mesosphere, if somebody was using Docker Swarm or some other orchestration platform for containers, it would be just as simple and easy for us to integrate, primarily because of the way our architecture works.
I know, and we're expanding that capability as well, and over time making because containers are such an important application set for the network these days. It's certainly a hot topic, and more of our customers are adopting container as an approach to insert simplicity and speed into their entire infrastructure. That's cool. So we're at the very top of the hour, and unfortunately out of time for questions. If you do have questions following, please feel free to send us an email at info@bigswitch.com. we do make it easy for you to get started with Big Switch solutions. There are several resources you can download or watch that will give you a tour of our products. In your handouts, you'll find that there are links to access any of these resources listed, including Big Switch Labs. With BSN Labs, you can experience Big Switch Network's bare metal SDN firsthand from the comfort of your PC. And we believe and have found that our folks researching solutions have no better way to learn than about a product or technology than taking it for a test drive and trying it out. For a free online real-time access to our SDN Fabric products, please visit labs.bigswitch.com. And again, the handout will provide you very direct information about how to access it and look at the modules both for Big Cloud Fabric in Complete or Big Monitoring Fabric. In conclusion, please join us Wednesday, February 28th for our next webinar with partners Portworx and Aqua Security. We'll be talking about containers in production, real-world solutions for networking, security, and storage. Watch your email for the registration detail, or check out our website webinar catalog for direct webinar registration. That concludes our presentation today. Thank you for joining us. We hope the balance of your week goes well. Appreciate your time. Thanks.